Good morning. Today we're going to use two of the problems that we looked at yesterday, and we're going to pull out from the function itself one last important feature, and that is looking at the zeros of the parabola. Well, we started this whole lesson on quadratics with looking at how to find the zeros of a quadratic equation because that's when we didn't have a y. The y was equal to 0. So this is going to be familiar. It's a wraparound to kind of close out all of our new lessons on quadratic functions. So let's go back to K hitting the fly ball. How many seconds will it take for the ball to hit the ground? Because that's when the height of the ball is at 0, is when it's on the ground. So we're going to just reuse the information from yesterday where x is the number of seconds it takes from the time the ball is hit, and y is the height of the ball. So we're going to find our a, b, and c. Our a is still negative 16, the b is 64, and the c is 4. We're going to fill them in the proper places in the quadratic formula, so I put a template here for you already. If x is the opposite of our b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, the a in this case, I should have written the negative 16 in there. So then I can simplify. X equals the opposite of 64 plus or minus the square root. 64 squared is 4,096. Negative times negative will be plus. 256 is what that multiplies out to be. Divided by positive 2 times negative 16 is negative 32. Okay, we're going to add under the radical. That gives us negative 64 plus or minus the square root. The sum of those two numbers is 4352. And I'm going to divide that by negative 32. I have to take the square root of 4,352, and when I do that, I get an irrational number. We'll round it to 2 decimal places. It will be 65.97 divided by negative 32. And then once I'm here, I can split into once the addition and once the subtraction. So let's do that off to the side here. I'm going to have x equals, don't forget that x equals, that's an important part of the equation, negative 64 plus 65.97 divided by negative 32. So if I add those two numbers together, I get x equals 1.97 divided by negative 32. I have a positive divided by a negative, so I'm going to get a negative 0.06. Now notice on this story, we're not looking at anything happening to the ball before she hits the ball. So that negative number is actually going to be somewhere over here. That's called an extraneous solution. It's mathematically correct, but it does not make sense to the story. So let's look at the other result we get when we use the quadratic formula. By subtracting a negative from a negative, I'm going to end up with another negative divided by a negative. So that will give me negative 129.97 divided by negative 32, which gives me a positive 4.06. So I'm going to plot the positive value on the x-axis. So 4.96 is a little bit more than 4. Okay, so that's the 0 of the function. If I name that point, the point name would be 4.06 comma 0, right? When x, that's the x value when the y is 0. The y is 0 when the ball hits the ground. So I'm going to go back and I'm going to label my x and y axes because I need to do that. X is the number of seconds, so this is time measured in seconds. And then this is my height, measured in feet. Okay, so I did that, I did that. We previously calculated all of this information, so that's yesterday's information, so I don't need you to recalculate that. I'm just going to use it. My axis of symmetry was where x equals 2. I'm going to make my dotted line just to show that's where the we could fold the parabola. It would be symmetrical on both sides. The highest point will be the vertex, and that's at 2, 68. Just right about here. Okay, the y-intercept was 4 down here. We can reflect that. And then we had another point at 152, and we can reflect that. And we can connect that. Now, mind you, the other 0 was down here, right? Off to the side. And then we're going to go, oh, no, it's a solid. And we go through. And you can see how the zeros complete the parabola, right? They make sense. They're in the right place to what was going on. And then I can go down from there. So, remembering that the ground has a height of 0, how long did it take for Kay's fly ball to hit the ground? I guess they missed it, right? So it would take 4.06 seconds. So we had a word problem. We need a word answer. For the ball to hit the ground. And we're done. So let's take a look at the other problem. Okay? You want to try it by yourself? Go ahead and pause this video and then you can start it again. The second problem, again, from yesterday's lesson, I used the same one. We have a rocket carrying the fireworks. X is our time in seconds. Let's go ahead and label our x-axis right now. So this is, again, time measured in seconds. And we're going to have y be the height of the rocket. So I have height measured in feet. We're going to calculate the zeros. So we're going to use our A, B, and C. So our A is negative 16. So I did 1, I did 2, I'm doing 3. 64 and 80. I'm going to calculate. So the opposite of B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. So x equals, simplify, negative 64 plus or minus the square root. 64 squared is 4,096. Negative times negative is positive. Multiply those three together and we get 5120 divided by negative 32. Taking the sum of the two numbers under the radical, we have negative 64 plus or minus the square root of 9216 divided by negative 32. Now, believe it or not, 9216 is a perfect square, so when I take its square root, I'm adding or subtracting 96, and I'm dividing that by negative 32. Once I add, once I subtract, x equals negative 64 plus 96 divided by negative 32 gives me a positive 32 over a negative 32, which gives me a negative 1. Again, on my graph, negative 1, if we extended the x-axis, would be about here. That would be 1, 0. And then I'm going to put the x equals negative 64 minus 96 divided by negative 32, which calculates to negative 160 divided by negative 32 which is a positive 5. Okay, so my second point on the x-axis will be here, filling in all the information that we had yesterday, which is written out on step number 5. I'm going to plot my axis of symmetry. I'm going to put the vertex on the axis of symmetry. I have my y-intercept. I have that reflection of the y-intercept, 1, 2, 1, 2. And then I have my additional point, which is right about here, and reflect that. So the part that's before the rocket was launched is part of the parabola, but not part of the story. So I just write that as a dashed, or you don't even have to put that part. I'm just putting that so you can visually see how nicely our parabola finishes. So, how long did it take for the debris from the fireworks to hit the ground? It takes 5 seconds until the debris hits the ground. Done. See how that ties everything that we've been doing together? Have a great afternoon.